Welcome back to Maths with Mr. Duffield. Had a person on Dr. Frost's Maths who was struggling with a couple of questions on simultaneous equations. Going to help you out here a little bit. Here's the first one. 4x plus 2y equals 9. X minus 4y equals 9. Going to label each of these. This is equation 1. This is equation 2. I'm going to do this by elimination, just eliminating either x or y, and then working out the one that remains. The first thing I'm going to do is take equation 1 and multiply that by 2. Every single item in the first equation doubled. So 4x becomes 8x, 2y becomes 4y, and the equals 9 becomes equals 18. If I pop the second one directly below it, you should be able to see that the equations are, the y parts of the equations, are both have a 4 in front, and because of that I'm able to eliminate them. I'll look at the signs on the front. If the signs are the same, we subtract. If the signs are different, we add. They are different, we're going to add both of these equations together. 8x plus x, 9x. Positive 4y, add negative 4y, eliminates it, disappears. I'm left with no y's. 18 plus 9 is 27. So divide both sides by 9, x equals 3. Nice. X equals, so excuse me, I haven't written that properly, 3. Okay? I'm going to put the 3 into one of these two equations. Why not the second one? I mean, it doesn't matter which one, but I might as well. So I'll substitute that into the second equation. So x is replaced with 3, minus 4y equals 9. So if I take away 3 from both sides, minus 4y equals 6. So y equals 6 over 4, but that's negative, yeah? Oh, excuse me. Let me just show you what I'm doing there. I'll just explain that again. Take away 3 from both sides to make that into 6 on the right-hand side, and then divided both sides by negative 4 to make negative 6 over 4. That obviously simplifies. Minus 3 over 2, if you like. You could write that as minus 1.5. It doesn't matter. So that's the first of the two equations I wanted to do today. The second one is here. Very, very similar sort of deal, really. It's still elimination. I'm still going to label both of my equations, and I'm still going to scale one up to make either x or y the same. And in this case, why it makes sense to double the first equation. Now, it might be that you have a question in front of you, in which case it's easier to make x the same. And that's fine. The method is very similar, depending on what you want to do. It's just in this particular case, on both of these questions, I've doubled one. It's not always going to be the case that I need to double one. I should make that very clear. It might be that one of the equations needs to be tripled. It might be that one of the equations needs to be times by 5 and the other times by 3, or whatever. Okay, so this is my first equation doubled. This is my second equation as it is. Again, positive and negative 4y means I'm going to add those together. 16x therefore equals 32, so x equals 2. Let's get into the habit of moving this up a bit more. So if I substitute that into, well, let's say equation 1, shall we? The numbers are relatively small. So it's 3 times 2 plus 2y equals 15. Okay, that's 6. Take away 6 from both sides. 2y equals 9, so y equals 4.5, or 9 over 2. So those are my pair of solutions for the second equation. I hope that makes sense. Once you really understand how this works, making one of the letters the same and then eliminating, it really doesn't take much at all. You just have to be clear with your method and consistent with how you apply it. Have a wonderful day. Don't forget to love each other. See you soon.